Hello all. Topic name is using SQL in data science. Let us see the concept. At the end of the session, students are able to know about the SQL concepts, basic concepts related to the database, and knowing the normalization about the your databases. And then first topic is getting a handle on the relational databases and SQL. And although this the same name SQL stands for a structured query language, it suggests that it is not a programming language. SQL is not a programming language. Actually, it is a language which is used to interact with the particular computer. Um, and SQL supports a few common programming forms like the conditional loops and loops, which are supported in a normal programming languages. And there are majorly there are three most popular open source SQL implementations among data scientists are SQLite, MySQL, and PostgreSQL. So these are the different versions of a particular SQL. Already we told that SQL is nothing but a structured query language which is used to interact with a particular computer. So there are different most popular open source SQL are SQLite, MySQL, PostgreSQL. So if you see that SQLite, this is a software which is more limited other than SQL. So SQL is one of the version and SQLite is one of the version. And in this software consists of a more limited rather than the SQL implementation. But it is a fantastic place actually to get started when you are first learning. So if you are the first learner, it should be very easy when you are using this SQLite. And the second one is MySQL. So MySQL is a far most popular open source version of SQL. Normally, generally, the students are using this MySQL packages. And mainly it offers a complete and powerful version of SQL and is used to backend of the millions of websites. If you are preparing the websites, so if the websites you are working, so background the some data should be stored. So for that databases, a normal thing is used as MySQL. And second, next one is PostgreSQL. PostgreSQL is also one of the type of SQL. The software adds additionally object-oriented elements to a SQL relational languages. And the next one is a primary key and a foreign key. So what do you mean by a primary key and what do you mean by foreign key? Actually, if you consider the table consists of a column. If I see this is a table, see here there is consists of a three types of tables, and these three types of tables are stored in the database, which is used for a lateral retrieval. And for lateral retrieval, data is going to be stored, and if we want to change the data, then it is also possible in SQL to change the data, to add the data, to update the data. And here, if you consider three tables, these three tables information consists of some lakes data. That lakes names are represented here. This is a column, and this is second column, third column, and this is consists of a row. So each row is nothing but a record, and every one is nothing but a cell. Here I am representing the three tables. This is table 1, 2, 3. So if you consider with this middle table consists of a name. The one is a lake name. This is nothing but a primary key. If you consider the other two tables, these two tables also having the first column as a lake name. These two tables are nothing but a foreign. First, these two table column names are we are considered as a foreign key. Why? Because these two foreign keys are linked with this particular main table. So if you consider this is a main table, this main table column name is primary key. If you consider there are remaining two tables which are linked with this particular primary key is nothing but a foreign key. So if you refer that primary key of a table is the column of values. If you see this primary key is nothing but a column of values that uniquely identifies every row in the table. So if you see this one, it will uniquely identifies the each row. If you see that Lake Monario and Lake Lily and Lake Conway, it will identifies the each row individually. So this is nothing but a primary key. If you see ISBN number for a table of books, or employee ID numbers for a table of employees. So if you see, this employee ID is nothing but a primary key. Based on the primary key, there are different types of foreign keys are there. If you see, next one is the foreign key. A foreign key is a column in one table. So foreign key is a column in a one table that matches the primary key of another and is used to link. So this one is used to link with the primary key. And focus on your terminology. If focus on your terminology, if you see, the data science often associates a particular meaning to a particular words. Nothing but if you see the columns are also known as fields, keys, and attributes, and rows also known as records, cells are also known as values. If you see, these column names are also known as fields or attributes. If you see, these rows are also known as record. If you see, this is one record, this is second record, third record, and everyone is nothing but a value, nothing but a single cell. If you see, this is an SQL create table statement. If you want to create a data table, how we are going to create a table is, this is a syntax: create table, table name, column 1, and this column which type of data type it is representing. If you see that employee ID, it is a mix of characters and numbers that we have to consider. If you see, that is a name, that is nothing but a character. If you see, that is a some roll number. If you see that the integer data type. So like that, we have to create a table name, insert a table name which we want to need, and have to insert a number of columns. And if you see, this is a syntax. If based on the syntax, if you see, this is an example. So create table, my table name is persons. In that, the column name is, first column name is person ID. Then the person ID may be a integer data type, and the last name, nothing but a last name should be a varchar. First name varchar, address varchar, city varchar. So like that, I consider the syntax. Based on syntax, I consider one example. If you see, if you implement, if you execute this particular query, if you execute this particular command, this particular table look like that: person ID, last name, first name, address, and city. So investigating some effort in the database design. So if we are going to design a database, we have to consider some principles. So what are the some principles is, we have to check whether data types, we have to check for a constraint, we have to check for a normalization. If you consider some data types, so what are the different data types? Main data types are text, numerical data. Text is already known, contains in text values. You can classify character data type with a fixed length or a data type. And second one is a numerical. Numerical is nothing but it is mainly used to hold a number values. You can classify it as a numerical data type. These can be stored as a integers or a float. And data. Date. If your column is to hold a date or time-based values, you can designate as a date data type or time data. So if you consider, so what are the different data types are text, numerical, data. And next one is designing constraint properly. So if you consider some, you have to remember some principles. Just now we discussed about the data types, and the second one is constraint. So already you know that constraint is nothing but some set of rules. Properly designed constraints are an important consideration in a data design. If you see that if you want to design a particular database, we have to make some constraints properly. If you see that if the data should not hold a null value, if you are not storing any value, it will raises an error that it should not be a null value. Like that, we have to give a constraint. For example, if you have a table of products you are selling, you are probably do not want to allow a null in a price column. So either maybe zero or either maybe in the price they have to fix. So if we entered a null value, it should be might be a problem. So that's why if we consider some constraints, then it should be very good actually when considering database. Next one is normalization. Next principle, just now we discussed about the constraints, and the next principle is normalization. What do you mean by normalization? Normalization is the process to eliminate data redundancy. If we are more data, nothing but same data is in another, same data should be in any other place, it should also be eliminated by the concept called normalization. And enhance data integrity in a table. Integrity is nothing but a combining all the data. And there are many different degrees and types of normalization. So if you see, there are many different degrees and types of normalization. If we see that primary key is one of the normalization as a primary, which is a unique value, and non-redundancy of columns, non-multiply dependencies, column indexes, subject matter aggregation. So these are the different normalization properties. And the next one is integrating SQL or Python and Excel into your data science strategy. If you see that integrating is nothing but a combining. SQL is nothing but a database, R Python is nothing but a programming languages, and Excel is also used as a database storage. If you want to integrate SQL capabilities into your R or Python workflow, every DBMS has a library or a module that you can use. Okay, so this is an and next one is narrowing the focus with SQL functions. The SQL when working with SQL commands, so already we saw some commands. What are the commands? These are the command. If you see, this is a command which is used to create a table, and like that we are having some other commands. When we are working some other commands, if you want to query some particular data in your data tables, we are using the function called select. To combine separate tables in one, we use it's called join function. So there are different command, different functions are there. So just some functions, some functions are introduced like that: select, from, join, where, group, max, min, count, average, and average. So these are like this. There are several number of functions, several number of commands are there, but we will discuss only the base concepts. And if you want to if I want to I'm going to explain the concepts by using some table. Let us follow the scenarios as an example. This table describes the films and list ratings from US. If you see, this is the ID, and these are the title films, and these are the genre, and this is a ramp rate, a rating timestamp, and this is a rating. The genre is nothing but a which type of movie it is. If you see the Fourth Man, this is a drama type of movie, and at this particular time interval, the particular rating is 5. If you see that in the before table, this table is in the single table, and this table can be separated into three tables like film table, genre table, a rating table. So in this the primary key for the film and genre is tables ID. So if you film is one table and genre is a table, the film ID and the genre ID is nothing but a primary key. And okay, then if you see that some functions select where date to query a data. So if you see that select star from rating. So here rating is nothing but a table name. So we are going to select star. Star is nothing but a whole thing. So whole thing we are selecting. But here we are giving the command called where. Where is nothing but what we are going to take the data. So which type of data in the rating table we are going to taking the data like rating dot timestamp greater than or equal to date of 2014 -01 -01. So we are here we are giving one instruction called rate stamp should be greater than or equal to this date. Only which are greater than this particular date only executed from a table called rating. So if you see this, there are one, two, three, four, five data are there. In that five data, only two data are greater than satisfy this particular condition. So like that, we are using the command called select, function called select, and we are using the function called where, and we are using the function called data. And next, there are different joins. Joins are there. Join is nothing but combining actually. Um, combining. So different joints are there: inner joint, outer joint, full outer joint, left joint, and right joint. So inner joint is nothing but it returns all records that lie in the intersecting regions. If you see that intersection, the two circles, what is that intercircle area? That type of that particular content is going to be displayed. This is nothing but inner joint. What do you mean by outer joint? Outer joint is nothing but returns all records that lie outside the overlapping region between the queried data. Queried data types. Outer join is nothing but intersection is nothing but inner join. Non-intersection is data is nothing but a outer join. But what is the full outer join? Full outer join returns all records lies between both inside and outside the overlapping regions between the query tables is nothing but a full outer join. So we will see each and everything. Actually you have to remember that inner join is nothing but it returns the record that lie intersection region, and outer join is nothing but that returns all records that lie outside overlap between queried data types. So let us see this particular concept by using the two tables called film table and genre table. If you see the first inner join, in the inner join, name specifies columns, film dot title and genre dot title after select the command. I do this to avoid creating a duplicate ID. So if you see this command, select the film ID, film title, genre dot genre from uh, room, join genre on genre ID equal to film ID. So if you want to join the particular two tables, so we have to give this particular statement like this. And nothing but what do you mean by join? Join is here I asked about the inner joint. What do you mean by inner joint? Inner joint is nothing but a intersecting part, intersection part of a particular one is nothing but the inner joint. And next one is full outer joint. Full outer joint is nothing but a whole thing we have to write up. So if you want to return all rows, even one with null value, simply do it full outer join like the one show below. If you want to combine all those things by using the concept called full outer join, we have to give a command like that: select film ID, film title, genre from which table, film full join. Here we give that join only for inner join, but full outer join we have to give full join genre on genre dot id film id. So then the executed data look like that. So this is an ID, title, genre. And next using a group statement to aggregate a data. Aggregate is nothing but calculating the average. So all these things are come under the statement groups called group by. The group by statements also open the aggregate functions like count, max, mean, sum, average to group the results set by one or more columns. So whatever the syntax is, select the column name from table name. So which column we are going to group by, where we have to give a condition. So by this is an syntax group by column name and order by. If you want to increase that order by we can increase. So this is a particular example by considering this group statement. Select film title. So here we are going to calculating the average rate as where we are going to take that average rating from which film table, and also joining rating on film id equal to rating dot id. So like that we can get the title and followed by the average rating. So this is nothing but a group by command. And next one is having a clause to narrow results. So here having clause represents the condition. Here having clause represents the condition. To narrow the results even further, adding a heavy clause at the end. So if you want to results a particular something, we have to add a heavy clause at the end. And by considering this particular one, here we are adding the average rating greater than or equal to 4. So which one having the greater than or equal to that one only? Here we printed the 3.5 also, but here it is aggregated as a greater than or equal to 4. So that's why only the two tables are going to be query. So, which type of questions you may be get is explain about SQL in databases, data science, explain about designing a constraint. Thank you.